Hey guys, welcome to chapter 12. We're going to talk about air. Now, the chapter should really be called Air Pollution, but here we go. Chapter 12, section 1, what causes air pollution? Your essential question, I want you to name 5 primary air pollutants and their sources. You'll need to know these because I promise you it will come up again and again, and especially on a test. So here we go. Air pollution. What is air pollution, if you will? It is simply the contamination of the atmosphere by waste from sources such as industrial burning and automobile exhaust. Kind of like the water pollution one, right? Anything that degrades the air quality of the things that live in it and need it to survive, if you will, which is everything basically on the planet. But substances that pollute the air can be in the form of solids, liquids, or gases. Because we can have liquid vapor, right? Gases, obviously, and solid particulate matter like dust or things that will be in there that may eventually settle and fall out. Now, most air pollution is a result of human activities, but some pollutants are natural, like dust. Dust gets kicked up into the air. You breathe it in. It's a pollutant. Pollen. Many people are allergic to pollen. Pollen in the air, certain types of ears. Spores from other plant matter, if you will. And we can get sulfur dioxide from volcanoes and also, forest fires putting carbon dioxide and other carbon particulate matter in the air. So there are natural forms of it. It's just that humans have done a bunch. This picture back here, this is LA, and that is a classic smog layer. We're going to talk about temperature inversions, which is why some cities like LA have more of this smog. This is a city in China, and this is not smog, this is just pollution, and it's largely created on a daily basis just from car exhaust and then factories burning. This is a picture of people in Nepal, and that is dust. You're driving on a dirt road, and it's very fine particulate matter, and the dust going up. So there's a lot of different reasons that we get pollution, but let's take a look. We're going to talk about primary and secondary pollutants. A primary pollutant. This is a pollutant that is put directly into the atmosphere by human or a natural activity. For instance, smut from smoke. You go out and you start a campfire, like I'm camping on the side of the river and we make a little fire. Well, the smoke coming off of that fire is soot. And that soot is ash, very small particles of ash, and it'll resettle down on things. Primary pollutant. When I burn a tree, I know I'm going to put it in the air. A secondary pollutant. A secondary pollutant forms in the atmosphere by a chemical reaction with primary air pollutants, with the natural components that are in the air, etc. An example of this is ground level ozone. We put nitric oxides into the atmosphere, but the nitric oxides combine with the water vapor and they create smog. Ozone mixed with the nitrous in the air. This nitric oxide, along with the sun coming through it, turns O2 into O3. But ozone at the ground level creates smog. Another secondary pollutant we talk about is sulfuric acid. Sulfur dioxide gets released into the air, H2O plus SO makes H2SO3, sulfuric acid. Let's talk about sources of primary air pollutants. Household products, power plants, and motor vehicles are just some of the sources of primary pollutants, such as carbon monoxide, nitrogen oxide, sulfur dioxide, and chemicals known as volatile organic compounds, otherwise known as VOCs, volatile organic compounds. Volatile, these are things that will combust. Things like paint thinner, just, really strong chemical smells, if you will. Vehicles and coal-burning power plants are the major sources of nitrogen oxide. emissions. Power plants, refineries, and metal smelters contribute most of the sulfur dioxide emissions. Then vehicles, cars, trucks, what have you, and gas stations make up most of the human-made VOCs, those gas vapors escaping from that. So when you and I are putting gas in the tank, as well as the refineries refining and creating it to begin with from the oil, create that. Here's a list of just some common volatile organic compounds. Benzene, xylene, toluene, styrene. Now toluene, we make mothballs out of it. You may not use mothballs much around anymore. And then styrene, like styrofoam. But these and their organic chemicals, they are petroleum products. They come from the oil industry, if you will, and these are some byproducts that we use for different substances. Now, when we're talking about this primary or the sources of primary air pollutants, particulate matter can also pollute the air, and we usually divide that into fine and coarse particles. How big is it that can float in the air? Fine particles, really teeny tiny guys, they enter the air from burned fuel, from vehicles, and also from coal burning power plants. Just kind of like your fire out, making smoke. When we burn coal, it makes smoke, but it tends to be finer particles, really teeny tiny, and they get up and can stay in the air for quite a while. Now, coarse particles, cement plants, mining operations, incinerators, things that are burning things up, if you will, and then wood burning fireplaces, just along with fields and roads. Coarse particles are really more kind of like dust particles in the air. When we're mining and we grind something up, it gets drifting up into the air, or the picture I showed you of the people in Nepal with the dirt getting up. These are typically coarse particles. They settle out of the air a lot quicker, but once again, as long as business is operating and the cement plants are going and we're mining, we're continuously generating it, and it goes on for a while. So we do talk about fine particles and coarse particles in the air. Now, air pollution is not a new thing. We can touch base on a tiny bit of history, if you will. But back in 1273, King Edward of England ordered that burning a particular type of coal, it was called sea coal, illegal. Sea coal created so much particulate matter, it burned so dirty that it was banned in London, specifically in the city there. He said, we're going to use a better type of coal because it made the city so dirty. So air pollution is not a new phenomenon. There's just so many people on the planet, and our technology has vamped it up. Today, the air quality problem in the world is much worse than it was in 1273 with King Edward I, because our modern societies burn large amounts of fossil fuel. It's going on 24/7. Our electricity has to be generated 24/7, and coal and oil is being burned 24/7 in order to generate it. Now, most of the air pollution in urban areas comes from vehicles and industry. This is where it comes from. You and I driving our cars around, as well as the power plants by and large, but also a lot of factories have to burn their own coal. They're generating their own electricity. It's cheaper for them to buy the coal and make it themselves than to just buy electricity from the company. So a lot of factories might be burning it themselves, or like a steel mill, right? They have to heat their metal up to high temperatures. So a lot of industry factories burn their own coal, burn their own oil, because it's cheaper in the long run to make the product. So when we say industry, a large part of it is our power companies, but not all of it. Also, motor vehicle emissions. 1/3 of our air pollution comes from gasoline burned by our vehicles. 90% of that is you and me. 90% of the emissions going into the atmosphere from cars, and once again, 1/3 from cars, but of this amount from cars, 90% of that is just regular people going back and forth to work, traveling, you name it. Only about 10% of that is like trucks and buses. We want to do the point source, want to point our fingers at, oh, it's all those big trucks on the road, it's the big buses. No, Most of it is just light duty, people traveling around, going to work, going to see grandma, you name it. It's sort of you and me. Now, in order to clean up our act, if you will, the Clean Air Act was passed in 1970. It was strengthened in 1990 by the EPA, the Environmental Protection Agency, and it gave the authority to them to regulate vehicle emissions in the United States. We gradually eliminated regular gasoline. Now, about all you can find is unleaded. There's a few places near farms where you can still buy leaded for some tractors, but as far as cars driving on the road, we use unleaded gas. It burns cleaner. Also, catalytic converters were required in all vehicles. The catalytic converters drastically cut down on the emissions coming out of the car. Basically, the car is burning its oil, its gasoline, creating smog and smoke, carbon monoxide, carbon dioxide, and some of these sulfur dioxides and nitric oxides. They come through the catalytic converter, and a chemical reaction occurs with the metals that are made into it, pulling a lot of these pollutants out into the catalytic converter, so what comes out the tailpipe is much cleaner. This made a drastic effect in the amount of air pollution in the United States from the 80s and into the 90s. Largely, our cars burn much cleaner than they did. They're still putting a lot of pollution. 1/3 of our pollution today is still coming from gas burning vehicles. I say gas, could be diesel, any kind of petroleum product. Now, many industries and power plants generate electricity have to burn fuel. The only way we really make electricity that isn't burning fuel, we have some solar panels, but it's still a pretty small amount. We have wind farms. Once again, it's still fairly small. Hydroelectric does not burn any fuel. And then we have nuclear fuel. Now, nuclear it burns clean. However, we wind up producing some pollutants in order to get the uranium. We have to mine the uranium, refine the uranium, and so it's used along the way. But once we actually have it in the power plant, it burns clean. But that's it. But that's not most of our power. Most of our power is coming from burning oil and coal. Burning these releases huge quantities of sulfur dioxide, nitrogen oxide into the air. And the power plants that produce our electricity emit at least 2/3 of the sulfur dioxide and more than 1/3 of all of our oxygen and nitrites. And these are what are polluting our air. Carbon dioxide is clear, we don't see it. Now, it's a greenhouse gas, but the nitrogen oxides, the sulfur dioxides, along with particulate matter, are what actually wind up causing the pollution. Now, some industries are also putting out the VOCs. Now, VOCs can wind up making you sick or dizzy or lightheaded. If you've ever been around some of these strong chemical compounds like toluene, styrene in its raw form, styrofoam is already a solid, so you can't really smell it. But things like dry cleaning, oil refineries, some chemical manufacturing plants, furniture refinishers, once again, paint thinner, mineral spirits, any of these things, and a lot of automobile repair shops contribute. And these VOCs go up into the air, contributing to degrading the air quality. And once again, just when you and I are using these things potentially around our house, it adds in, they escape and they add into the atmosphere. Let's talk smog. Smog is a very specific problem, and it is an urban air pollution, and it's composed of a mixture of basically car exhaust and industrial pollutants along with ozone, the nitrogen oxide, and the air. So in the air we have oxygen, O2. The nitrogen oxide that goes into the atmosphere, the sun comes through and hits it, and it gives enough energy to turn O2 into O3, ozone. So the pollutants that are released by vehicles and industry they're the primary pollutants. These primary pollutants create a secondary pollutant, the ozone, and this all hangs down really close to the ground, causing smog. And smog winds up being a huge problem in particular cities. Now, as a general rule, warm air rises. So the smog and pollutants usually would ride up and then kind of drift out and not be as much of a problem. But in a lot of cities, especially those with mountains on a couple of sides, we get something known as a temperature inversion. So normally the heat that warm air rises, it pushes the stuff out, gets up into the upper atmosphere, and it kind of clears out the air, at least disseminates it, and it's not as concentrated. Well, as this warm air rises up through the cooler air, in a temperature inversion, we get a warm layer of air here. A lot of times if we have mountains, it's coming up over the mountains. So this warm air rises, it hits this other warm air layer, and it can't rise anymore, and it stops right there, and then the smog begins to fill down. And this creates a really bad smog layer. This is the picture up here of LA again. You can just see it, it's hovering right over the city. So this pollution gets trapped near the Earth's surface by this temperature inversion, and it hits it, and it just begins to push its way down. This temperature inversion traps this cooler air under this warm air, so the pollutants just continue to fill up, and it creates a problem. So anytime you have cities in a valley, like LA, it's got mountains on three sides, they tend to experience these temperature inversions. When I lived in Kathmandu, Nepal, it was in a bowl. You had mountains all around, and the warmer air would blow up over the mountains, and the cool air here had nowhere to go, and this bowl just filled up with smog. Oh, and it could be awful. You couldn't see more than 2-3 miles some days. Some days we had a nice, real high pressure system. We didn't have the temperature inversion. The air would drift. It'd be beautiful. You could see the Himalayas way off at a distance, but from day to day, we created enough pollution in Kathmandu that you typically couldn't see out of the valley. Well, guys, that wraps it up for air pollution today, and we'll see you next time. Take care.